Hi all, electrical engineer, Igor Ekimov, is with you. Today we'll look at a 2C23T2 channel oscilloscope with a generator and a multimeter from FNIRSI. This is a compact and fully functional 3-in-1 device. If you follow the channel, you have probably already seen that I have already used this device in videos as an oscilloscope and generator. I like this device because of its wide range of functions and completely intuitive controls. I'll talk about all this in this video. If you are interested in reviews about electronic devices, then subscribe to the channel and press the bell. Special thanks for your likes and reposts. The device comes in such a beautiful package. Beautiful packaging is FNIRSI's calling card. The device is suitable as a gift for lovers of electrical and electronics. The characteristics of the device are briefly described at the bottom of the packaging. More detailed information about the characteristics of the device can be found in the device passport, or by following the link in the description. Open the box. At the top is a passport in several languages. Operation of the device is described in some detail. It is especially valuable that examples are given of how to solve specific problems using the device. And here is the device itself. I have already removed the package from it, since I have already used it more than once. The device is packed in a polyethylene foam box, which ensures the safety of the device during transportation. Let's remove this box. Below it is a second box with cords. On top there is a cord for an oscilloscope with a divider X1x10. It comes in a Ziploc bag. The kit includes additional accessories for it. These are caps for the dipstick, a screwdriver and colored rings. Here is the probe itself. Here is the input to the oscilloscope. To connect to the device body there is such a crocodile. There is such a catch here. The hook can be removed, and there is a needle for measurements. You can put on the caps and the dipstick will look like this. Or like this. Using this screwdriver, you can adjust the compensation of the probe capacitance to improve the display of the meander along the fronts and bottoms. Here you can adjust the probe capacitance compensation. For the generator there is also such a cord without a divider with crocodiles. And these are probes for a multimeter. The cords are quite soft. It is written on the probes that they are designed for voltages up to 1000 volts and currents up to 20 amperes. The probes have caps to prevent oxidation. They can be removed. Here are the caps. Remove them. The probes are very sharp and have a golden tint. And this is a cord for charging and connecting to a computer. To charge the device, you need a 5-volt USB power supply with an output current of up to 1 ampere. Since the device is a 2-channel device. Another cord for the oscilloscope was sent with the device, which did not fit in the box. As a result, we can use all 3 outputs of the oscilloscope and generator, which I will show a little later. The device has such a unique design. The developers did a good job on it. The plastic from which the device body is made is of high quality. The device has rubber shockproof bumpers at the corners, which also give it an interesting design. The device fits well in the hand. On top there is a 2.8 high-definition LCD screen with a resolution of 320x240 pixels. Just below is the keyboard, which is easy to understand intuitively. There is a keyboard joystick in the middle, and function keys around it. We will analyze the keyboard in more detail when we study the functions of the device. Below are the multimeter inputs. 1 common, 2 current connectors, and 1 for other measurements. There are 3 connectors on the front. 2 oscilloscope inputs CH1 and CH2, and generator output. On the side, behind a rubber plug, there is a Type-C input, with which you can charge the device, change its firmware, or upload saved waveforms to a computer. The charge indicator is visible through this hole and glows red when charging. Inside the device there is a lithium battery with a capacity of 3000 mAh. The operating time of the device can reach 6 hours. There is another hole nearby. Using the pin, you can reset the device in case of possible freezing. Here is the bottom of the device. There are even 4 legs, which are usually not provided in other devices. There is a hole where you can hang the device on the wall. And there is a folding stand. And the device is more convenient to look at, and it takes up less space on the table. Due to the rubber bumper, the device does not slip on the table. The oscilloscope has small dimensions of 167 by 89 by 35 millimeters. Its weight is 300 grams. Turn on the device by briefly pressing the Network button. The device booted up quite quickly, and the home screen turned on, where you can select the operating modes of the device: an oscilloscope, a generator, a multimeter, and setting up device parameters. Switch with the buttons left and right. To select a mode, press the button in the middle. I will look at these 4 modes separately. The screen is color and quite bright. It has good visibility from different viewing angles. There is a protective film on top. I like this device, and I'm definitely going to keep it, so I'm taking off this film. First, let's look at the oscilloscope mode, since the device is usually purchased because of it. I'll look at the other 3 modes later. As you can see, both channels are shown simultaneously, but each channel is controlled separately. Here 2 cords are connected to supply a signal to the oscilloscope. The CH1 key controls the first channel and the CH2 key controls the second channel. We can choose which channel to control. Here I turn on channel CH1. If I press it again, the context menu turns on. Using it, we can turn the channel on or off. Select which divider we have on the cord. And select the channel input for direct or alternating current. Let's close. In the same way, you can adjust channel 2. Here we see that the adjustment is on channel 2. Click again, and it shows the same settings. Turn it off. Auto button automatically adjusts the oscilloscope readings. Long hold, line calibration. In this case, both lines appear in the center of the screen. A short press on the middle joystick button enables screen capture. And the waveform stops. At the same time, the red dot lights up. Holding the center key for a long time will center the lines. But the level of the lines will be different, the same as you see on the screen. Using the Save key we can save the current value of the oscillogram. By holding it for a long time, we can enter the device's memory with saved waveforms. Using the keyboard joystick and function keys, we can manage saved waveforms, if desired. These waveforms can be downloaded to a computer and viewed on a larger screen. Just connect the device to your computer, and it will recognize the device as an external drive and display a folder with saved images. They can be transferred to your computer. We exit the mode. Let's see the values that are displayed on the screen. A green dot means the oscilloscope is in signal receiving mode. If we press the middle key of the joystick, the dot turns red and the oscillogram freezes. We're filming. The next value is the time sweep per cell. Using the left and right keys we can change this value. The time base can be adjusted from 50 nanoseconds to 10 seconds per division. The sweep frequency affects both channels at once. The following shows which channel control is currently active. The operation of the signal generator will be displayed here if it is running. And we will do this a little later. The device allows you to apply a generator signal to the input of the device, and then check the operation of the device with an oscilloscope. The following shows the charge level of the built-in battery. If it is at the red level, then the device should be charged. On the right is a trigger mark that can be adjusted. and assigned to the first or second channel. The voltage swing is shown below, on the left for the first input and on the right for the second. For each input, you can set the voltage swing separately and set the position of the divider on the cord. The vertical scan is adjustable from 20 mV to 10 volts per division using the up and down buttons. As you can see, for adjustment we have the second channel active, and here we adjust the voltage swing. It should be taken into account that the measured voltage with dividers X1 is up to 80 volts, and with X10 up to 800 volts. It is forbidden to supply voltages greater than 400 volts with dividers X1. In the middle are the trigger settings. We see that the trigger is in auto mode, and the trigger label is tied to the second channel. The oscillogram for the first input is displayed in blue, and in orange for the second. At the top, the cursor shows the horizontal position of the oscillograms. It works on both charts at once. Below you can turn on the display of additional parameters, or you can turn them off. There are 4 buttons on the top. The leftmost one involves moving the waveform. A cross will light up here, indicating this mode. Use the up and down buttons to move the waveform. From above we see how the mark moves, and the oscillogram will move with it. You can move slowly with single taps, or hold for a long time to move quickly. The position can be understood by the marks. The active tag is marked in red. These 2 marks indicate the 0 level of each waveform. If we are in another mode, for example a multimeter, then holding this button for a long time switches the device to oscilloscope mode. The next button is to set the trigger label. At the same time, such an arrow lights up. Using the up and down buttons we can move this label. The label is tied to the oscillogram that we specified with the trigger settings. If we hold this key for a long time, we switch to generator mode. We return to the oscilloscope. The next button is to configure the trigger itself. Here we can choose whether the trigger will work in automatic mode, normal mode or single mode. Let's go back. Here we select which waveform the trigger label is attached to. Let's put on the first channel. And here we adjust whether the trigger is triggered by the front or by the fall. We exit the mode. If we hold this key for a long time, we switch to multimeter mode. We return to the oscilloscope. And the right button is to configure the displayed additional parameters of the oscilloscope signals. We press and with the keyboard joystick we can select which parameters we will display. Press again and exit the mode. By holding this key for a long time, we can enable additional options. Also, by holding for a long time, we can turn off these parameters. The oscilloscope's transmission frequency is 10 MHz. At the same time, the discrediting frequency is 50 MHz. Input impedance 1 mOhm. If anyone is interested in Lissajous figures, this oscilloscope does not do them. We will return to this oscilloscope mode later when we study the signal generator. Press the menu button and get to the main mode selection screen. Select a generator. We could quickly switch to this mode by simply holding down this button. The generator can output 7 types of function signals, with a maximum output frequency of 2 MHz for all signals and 1 Hz steps. The output frequency, amplitude and duty cycle of the signals are adjustable. The amplitude is adjustable from 0.1 to 3.3 volts, in steps of 0.1 volts. Using the up and down buttons we can select the waveform: sine wave, square wave, trigonal, half wave, full wave, noise, and constant level. Using the keyboard joystick, we can move to the right side of the screen and adjust the indicators more precisely: its frequency, duty cycle and span. Each digit is adjusted individually by settings. This way we can adjust the waveform as accurately as possible. The resulting waveform is immediately displayed on this graph. As the waveform is selected, we can turn the generator on or off. The generator is now turned off. And now the generator is on. Let's send a signal from the generator to the oscilloscope. To do this, we connected the probes to the output of the generator and to the first input of the oscilloscope. The probes were connected to each other, body to body, signal output to signal output. Let's switch to the oscilloscope. We turn on the auto mode, and the oscilloscope itself selects the optimal form of signal display. Here we can move the oscillogram left and right, down and up. Let's adjust for decline. Here we can expand the oscillogram. If desired, we can switch to another channel. We also turn on the car. Here we have it adjusted in automatic mode. But in order for us to record an oscillogram, we need to switch the trigger to the second channel. So we take it, switch it. And our mark is already near the second channel, and the oscillogram has stopped. Let's put a rectangular signal waveform. Here we have a meander. We can narrow it, expand it. We can remember it. And it appeared among the saved oscillograms. We can select it and delete it. Let's exit this mode. We go to the generator, turn it off, disconnect the cords. And now let's switch to multimeter mode. To do this, just hold this key for a long time. The device immediately switches to auto mode. In this mode, resistance levels and voltage are measured. AC or DC voltage is determined. Dialing does not work in this mode. I prefer not to use the automatic mode, but to choose the measurement modes myself. With the left button we can select the measurement of DC, AC voltage, as well as circuit resistance. Let's measure the battery voltage. Thus we connect the probes to the device. Take the battery and select DC voltage measurement. We connected the battery. Here is the measured voltage of this battery. Press the middle button. The hold mode worked. This value was remembered in the device's memory. Now we can disconnect the battery, and the readings are saved on the display. Press again and the freezing is turned off. The device selects the measurement range itself. There is no manual adjustment of the measurement range. You are unlikely to use the rail function, relative measurements, because it only works in capacitance measurement mode. Also, please note that in multimeter mode the battery charge is not displayed. However, for this device, the multimeter mode is additional. The main one is an oscilloscope and a generator. It copes with these modes with an A+. But the multimeter mode of this device is sufficient for most measurements. Switch to AC voltage measurement mode. The readings that we see now are tips from the probes. We can short circuit the probes. As you can see, the readings have reset to 0. We measure the voltage in the outlet. Ours shows 231 volts. Switch to resistance measurement mode. Let's measure. We see a reading of 2.36 ohm. Press the next button and get into the diode measurement mode. Here we take the blue LED. As you can see, the device lit it, and the drop at the PN junction is 2.58 volts. Checking the dialing mode, we close. As you can see, the device copes with dialing quite quickly. As you can see, when shorted it shows 0.1 ohm. Press again and switch to capacity measurement mode. We measure a capacitor with a capacity of 330 nanofarads. 332 nanofarads showed us that it works. Press the third button. We get into the phase determination mode. To work with this mode, one red probe is enough. The phase is located here. This is accompanied by a signal and a pattern on the screen. We look at the other contact of the socket. Here we have a 0. Press again. Here the device determines the temperature in degrees Celsius. While the thermocouple is not connected, it detects the temperature of the internal sensor. The device has been working for a long time and it shows 40 degrees. We press again, and we see the same temperature in Fahrenheit. I suggest not trusting the internal sensor, but still connecting a thermocouple. Press the fourth button. In this mode, the device measures direct current up to 10 amperes, direct current up to 1 ampere, alternating current up to 10 amperes, and alternating current up to 1 ampere. Let's measure the short circuit current of the battery. This is how we connect the probes of the device. We select direct current up to 10 amperes. We connect the battery, and it shows 1.5 amperes. This battery can still be used. If we need to measure current up to 1 ampere, we switch the probes this way, and then select current up to 1 ampere. It's the same with alternating current. You can see the multimeter parameters on the screen. If you want to study the table in more detail, stop the video. You can also view the device parameters by following the link in the description. Now I'll move on to the device settings. We enter the menu. Select the parameters. The first setting is to select the language. I choose Russian. The next setting is the speaker volume. I usually put it somewhere in the middle. The next setting is the auto power off feature. I chose 1 hour. You can choose at your own discretion. The next setting is screen brightness. I bet the maximum. With this setting, it is worth considering that the brighter the screen, the faster the battery will drain. With the following setting you can set which mode will turn on by default when you turn on the device. For example, let's choose an oscilloscope. Here is information about the manufacturer, device type and firmware version. The next function is a factory reset. Let's take a look at the device. To do this, we need to unscrew these 4 screws in the corners, and also these 2 screws under the stand. Here are the insides of the device. Pretty good build. Here are fuses that protect against overcurrent, 1 amp and 10 amp. If your device stops measuring current, then most likely they are burned out and need to be replaced. And here is our battery. Its characteristics: 3000 mAh and voltage 3.7 volts. As usual, some of the microcircuits are without inscriptions, which complicates the repair of this device. We assemble the device. Here's a review. The device is good and worth the money. I will be using it in the near future as an oscilloscope and generator. I will only use it as a multimeter when I use it as an oscilloscope. If you have any questions, write them in the comments. If you have experience working with this device, or a similar one, you can tell us about it in the comments. By tradition, I leave a link in the description to the supplier of this device. Share the video with those who are interested in similar devices. Subscribe to the channel so you don't miss new videos. Like and see you in new and old videos.